So I'm going to give you a brief instruction on how to manage infrastructure as code. So start a little quick. I'm not as crazy as Carlo. I don't climb rocks. I'm afraid of heights, but I do like to walk in the mountains. When I work as the principal architect at Pingdom. Pingdom is part of the SolarWinds Cloud. I'm located in Sweden, more in particular a city called Västerås. My primary focus is the backend architecture for Pingdom. I'm also engaged in the infrastructure and some part of in the front end. So, quick introduction to Pingdom for those who not are familiar with us. We mainly do uptime and performance monitoring, and by doing that we do two types of monitoring. We do synthetic monitoring, where we have probe servers across the world that actively sends a request to the target system. We collect some data, we analyze it and store it. And then we have real user monitoring, where we sort of act passively collecting data and store that and process. Obviously, we have stuff like alert management, reporting, and other stuff that are maybe not that interesting. So to give like a good user experience for the customer, we have a lot of servers spanning across the entire globe, multiple regions, multiple data centers, tons of servers, tons of Docker containers. So we have a fairly large and complicated and distributed infrastructure. So for us, it's super important that we're able to manage it correctly, spin up servers in new regions, or spin up a test environment or whatever. So along all these requirements, we have like very different problems. Like you can have different kinds of services requiring different hardware. So for instance, you can have like a lot of small APIs that doesn't really need that much memory or doesn't need that much compute power, but you can have like a database system that requires huge amount of memory, a vast majority of IOPS because you're reading random reads all the time. You could have file-based storages that does sequential reads. You have different message system, you have streaming data systems, you have all this kind of different stuff that have very different hardware requirements. To make it even more complicated, you usually have multiple data centers. You want to have redundancy. You probably want to have redundancy across multiple regions, so you want to have maybe some GeoDNS system that offload the data to another region if one region goes down or somehow loses connectivity. Security is up in there, I heard, so you need to have different security rules or firewalls protecting the services from each other. You might have like a sensitive finance system that, for instance, the normal backend system shouldn't be allowed to talk, so you typically have like some firewalls or some other access-based rules that prohibit the services to talk to services they are not supposed to talk to. For APIs, you typically would like to have a good spread across multiple data centers, across regions. You want to have a load balancer that knows about where those APIs are located. You want to have, for instance, some sort of service discovery or other kind of mechanism. Yes, Alex and Garish mentioned, you have a lot of logs. You need to manage that, so make sure that all your logs are stored like not at the nodes, because it will be impossible to SSH into each machine to get the logs. You need to have a centralized log management system, which is making it much easier to manage the software. And on top of that, you obviously will have some monitoring and alerting system, because you want to be notified that something goes down or break, or is maybe you can even be warned before it breaks by monitoring the correct metrics. So it's obvious that you will fail if you try to do this at a scale, if you're doing it like by hand or manual. So you need to have some system that makes this for you. Even like creating this huge infrastructure from the beginning by hand, it's going to take forever. And especially if you want to create a identical test system that is like smaller but still has the same functionality, it's very easy to do some misconfiguration or do something in the wrong order that might get the system to behave in a different way that you want to. So there are lots of pitfalls that you can walk into. You don't, for instance, you don't want to have like a Snowflake server that is a server that is slightly misconfigured or configured different than it's supposed to be. So it might cause some problems, or even worse, it might work whereas the other one doesn't, and you can't understand why it's working. So there has to be some kind of automation going forward. So there are some different tools that does this for you. You could sort of classify them into two different categories, and that's configuration management system or configuration management tools, and then you have like orchestration or provisioning tools, and they're typically not used for the same kind of features. You usually have a configuration management system or configuration management tool to, for instance, install the drivers, install some packages, create config files, all these kind of things that require that you have some hardware to run it on. On the other side, you have some orchestration tool that spins up the hardware for you. So so it spins up the hardware. And usually a big difference with the orchestration tool is that they sort of keep a shared state that keeps track of what's going on. So that allows you as a user to create some more complex scenarios. You can sort of reference other system that you just have configured, so you can sort of use variables to bind the systems together, whereas in the configuration management tool it's usually not that easy. You can do some custom development in the language they're written in to sort of extend them with new packages, but it's usually hard and might not be a long-term solution. And also I have listed some examples of some tools, but you should keep in mind that sort of the tools are merging. Multiple tools do sort of both provisioning and the configuration management. So how do you describe your infrastructure as code? Well, there are two sort of different ways, and I would say those are the two biggest ones. You either do declarative description or imperative description. And if you're familiar with programming, these concepts are roughly the same. In imperative, you describe the steps you want to do to achieve the desired state, whereas in a declarative way, or in a declarative tool, you describe the state you want to have, and then the tools figures out what kind of steps that needs to be done to get there. So those are the big difference. Obviously, there are some benefits with some of them. The biggest one, I would say, for the declarative version is that it kind of treats the infrastructure as immutable. If you do a change in the configuration and apply the rule again, probably it will kill off the sort of affected instance and restart them and reinstalling them. So you sort of pretty much always sure that you get the same state. That can not always be the case for an imperative way, because during all this sort of incremental step to get to the final destination, final state, some side effects might have been introduced and maybe not cleaned up correctly. So there are some potential problems with that. So just a typical example of an imperative task. So for instance, we want to have 10 instances containing a specific OS image and a specific hardware type. So this is like really simple. We want to have 10 of these, and what that will does when we run it, it spins up 10 instances. You run it again, it spins up more instances. So now we have 20. So for instance, you want to downscale. How do you do that? Well, first of all, you need to figure out how many instances are you running, and then you sort of can create a task that will sort of decrease the amount of instances. A declarative way is slightly more easy to work with, because you say you want to have 10 instances, you have the same OS image and the same hardware type, you run the job, create 10 instances, really good. You run the job again, it will see, okay, you are running 10 instances, and you said you only want to have 10, so I do nothing. So it's really sort of foolproof in the sense that it's idempotent. You can run the job as many times you wish. It won't alter the state. So, sorry. So a slightly more advanced example. Just I want to show here like how you can tie different resources together. So, for instance, we can reference some other security group, which is pretty much a firewall. We can tie in an already existing load balancer and tie this into this module. We can also see that I have a source which referencing something else. So in that sense, you can sort of have sort of object related inheritance across your model. So you can like build and continue and expand on existing modules that you maybe, I don't know, find either in your office or on the web. There are a lot of open source stuff going on here as well. So yeah, so when you're using infrastructure as code, this kind of follows in some sense the regular life cycle or workflow that you use when you're working with regular software. So it kind of, you have easily like version controlled infrastructure. You can see what works, what did not. You can different versions to each other to see what kind of changes was added that potentially broke or changed the infrastructure to a way that we didn't like. You can very easily collaborate. Like you can use your regular workflow. Like you create you create a new version, you create a pull request, someone reviews it, they can test it, like to see that it's actually going to do what you as a developer or SRE guy want to happen. Obviously, as I said, with modules, it's easy to sort of expand going forward. You can easily manage multiple identical environments, and often you can sort of plan or do a dry run to see like, okay, this is the actual steps that will be performed to sort of apply this new patch you have loaded. So you can like inspect it, see what's actually happening, and if you're fine, you can apply it. So get some extra safety check. So when you're running a large infrastructure, you have to have some kind of monitoring, which everybody here at SolarWinds should know. It's super important. So one really good benefit with infrastructure as code is that allows you to add monitoring immediately next to the infrastructure. So you have a lot of different providers that you can use to add monitoring in slightly advanced use cases immediately into the infrastructure description, so you can have like multiple alert policies being described as well. So just gonna skip some slides so we don't take all the time. So going forward, like with infrastructure as code, you need to have some kind of deployment scheme or deployment pipeline so you can deploy your actual applications onto this. So in that sense, we like to have like a very general deployment pipeline. So we can see like the deployment is a function that takes 2 arguments, which would be like the new version to apply and an environment. An environment could be like system test or staging or whatever. So to relieve some of the work from you have to have like a really complex or really good deployment system that kind of can extract the information like, okay, you want to go to this environment, what kind of nodes have I, where are they located, how can I reach them, and what sort of do I need to change the deployment artifact somehow before I go there and deploy them. And yes, you usually do, because you typically want to have like the security credentials in a separate store that's not available to the developers. You need to sort of bake them into the artifact that you deploy before you go there. So that's like, it's kind of crucial that you don't mix up security credentials with your code. And yeah, obviously you need to be able to spin up the product, otherwise it's kind of worthless going to deploy it anyway. So if you look back, I talked a little bit about monitoring, but how what kind of requirements do monitoring have? Like, yeah, from a developer perspective, you want to add monitoring into your code. Like, you want to, for instance, measure critical events. You want to do timing. There are a lot of things that you can, that are of interest to monitor. There are some benefits, of course. You can use like an APM solution like AppOptics that will immediately extract tons of valuable metrics and push them to the monitoring system without you as a developer doing that much. So it's gets a lot of metrics for free. Obviously, you should sort of keep going forward, like monitoring the end user experience, and Pingdom is typically a good choice for that. So that's also something that you want to consider. So some of the pros by using this is like, yeah, as I said, you can follow the development flow that's been around for a long time. So I have like a really good methodology to fall back on. So you can work in like an agile, iterative way. You can start small. You can building up larger and larger infrastructure, testing as you go, backtracking if something didn't work. Okay, take a different path, go forward. So in this sense, I sort of recommend that you like try really hard with these new creative ideas you get, because it's very easy to, if it doesn't work, you just change the configuration, apply it again. The old system that didn't work, it gets killed off, and you can sort of start from fresh again without really risking of introducing any unwanted behavior into the system. So yeah, everything is not sunshine. So there's like something you need to sort of plan immediately when you begin, and that's like a lot of these tools doesn't have like a good namespace solution, so you might need to pay some attention on the names you pick, so you have like a consistent naming schema across the entire infrastructure description. So otherwise it will be really hard to collaborate, because yeah, it kind of gets messy. I mean, imagine having this huge code project without namespaces, like plain old C again. It's a mess. It doesn't really scale. Usually you have some other requirements on the application, like for instance 12-factor app is a really good one that makes it easier to manage the infrastructure as well, because for instance you can use a more homogeneous infrastructure that doesn't have like all these special libraries installed or everything. So from an application perspective, you bake all the dependencies into the container, and then you can pretty much deploy to any available host. So yeah, you should also like go on, use the tools that you have, and plan big but start small, because it's kind of easy that you get this really huge vision that we should do everything, and you start immediately, and then you sort of halfway into the project you realize that you have like not thought things through, and you sort of end up in a situation where you sort of can't get out. So start small, try it out, apply it to multiple systems, and then just continue grow as you go. So that's it.